Hello, good morning. In this video lecture, we are going to discuss about cognitive spectrum management. So, in this, we are going to discuss about cognitive transceiver introduction as well as cognitive transceiver architecture. So, first we are going to discuss about cognitive radio introduction. So, cognitive radio means here we are going to deal with the help of a spectrum. So, spectrum is a finite resource. Efficiently use of available spectrum is key requirement for wireless system design. So for wireless communication, here spectrum plays a major role. So here spectrum means within the limited spectrum, we are supposed to go for better quality of service in especially wireless system design. So wireless communication, which is going to be work with the help of a frequency. So in this cognitive radio, it's going to be in the range of 6 MHz to 10 GHz. The large area service are catered by less than 1 GHz. So the limited bandwidth which is going to be available. Then we are going to discuss about spectrum usage management. So here we are going for two approaches, regulatory approach as well as cognitive radio approach. So first we will discuss about what is meant by regulatory approach. Assign a spectrum band to a particular service and even a particular operator. It allows network planning and good quality of service, but it is a waste of resources. So regulatory approaches means here we are going to assign an spectral band to a particular service and then to a particular operator. Then it allows a network planning and good quality of service, but in another point of view, here we are going to waste our resource. How we are going to waste our resource means it is going to be an wired communication. Wired communication means from sender to receiver. Here we are going to connect the system with an wired cable. So wired cable means it will be an work with 24 cross 7. Whether that user and then sender they are going to be communicate 24 cross 7, it doesn't matter, but there will be a reliable connection between sender to receiver 24 cross 7. So the same system, if you are going with the wireless system means whenever the sender they want to communicate to the receiver, by the time they can use the spectrum, in meantime the spectrum will be remain unstable. So once it is going to be remain unstable means the other user, those who want to use spectrum, the same spectrum they can able to use and then they can communicate the sender. So in that way we can able to use the spectrum efficiency in better manner. So that was regulatory means here we are going to waste our resource. How means and spectrum which is going to be allocated only for particular service and then particular operator. It doesn't matter, they are going to be communicate for all 24 cross 7. At last here we are going to waste our resource. That is an regulatory approach. Another approach, cognitive radio approach, in which the user adapt to the environment included in the existing spectrum usage. That is nothing but here we are going for wireless system. So whenever the usage, the user they want to communicate to the sender, by the time they will use the spectrum and then meantime they will disconnect and then it will remain unstable. So in this way here we are going to see the cognitive radio approach. Types of cognitive radio. First, ideal, a fully cognitive radio or Motorola radio. Adapt all transmission parameter to the environment, that is modulation format, multiple access method, coding, center of frequency, bandwidth, transmission time, and so on. So these are all taken care. And as a scientific curiosity, too complicated for practical purpose. So what is the practical purpose? Means the spectrum sensing cognitive radio. Adapt the transmission frequency, bandwidth, and time according to the environment. It is an dynamic spectrum access. Dynamic spectrum access is whenever they want By the time they will access, they will go for the spectrum sensing. Once the spectrum is going to be free, they will use the spectrum in order to communicate from sender to receiver. So that is the DSA, dynamic spectrum access. Motivation for DSA. A key motivation for DSA comes from the fact that the current fixed assignment spectrum is not exploited to its full extent at all times. Example, no active user are present in a cell for a cellular system. The spectrum is unused in a particular area. Similarly, a lot of spectrum assigned to a TV transmission, it is not used. In general, this problem of white space spectrum is quite pervasive. For example, investigation in the USA estimates that most location only 50% of a spectrum is used. So these are all the points we are going for DSA. Why? Because means no active user are present in a particular cell, then spectrum is going to be unused. Similarly, the lot of spectrum is assigned for TV transmission, it is not going to be used. As per the investigation by the USA, nearly 15% of spectrum it is going to be used. So another 80% of spectrum we are going to be unused. So that only here we are going for dynamic spectrum access. Right. Model of DSA. So first, dynamic exclusive model. Spectrum reserved for particular service, but a different provider can share the spectrum. One spectrum is going to be reserved for a particular service. Even though they are not going to be used, the spectrum, they can able to share to some other user, that is different user. That was the first point. Joint usage of a single large frequency band result in higher spectrum efficiency than the use of n small band by n separate operator. So this was the second point. Either by a single cellular operator or by a construct of operator, which is going to be an resulted in higher spectral efficiency than the use of n smaller band by n separate operator. Sharing of the spectrum through threading is going to be better. Last, regulator assigns spectrum to a particular user or service on a exclusive but time varying basis. For example, cellular provider might have the rights of use 50 megahertz of a spectrum in the morning and only 20 megahertz at the noon. Why? Because means even though here we are going for regulatory assign of a spectrum to a particular user, depending upon the time varying basis. Time varying basis means morning there will be a large user. Why? Because means they want to catch the train, they want to catch the bus, they want to book Ola, Uber, like that. So everyone they will be communicating with mobile phone. Once they are going to be settled down in that office, then they will put the cell in silent mode. So comparatively from 8 to 5, only 20% of the user they will be use their mobile phone. So that was the scenario. A regulator assigns spectrum to a particular user or service on a exclusive but time varying basis. That was the thing. Next. Second model. First model dynamic, second model open sharing. All user can access the spectrum equally, subject to certain constraint on the characteristics of the transmitting signal. By the name itself, you can able to come for an assumption it is going to be an open call. So open call means it is going to be available for all the users depending upon the usage. Whenever the spectrum is going to be free, so they can able to use for their own communication. So all users can access the spectrum equally, subjected to certain constraint on the characteristics of the transmitting signal. Second point, this approach is used in the industry, scientific, medical. That was the next. The free access and the easy of a type approval contribute to the popularity of Wi-Fi. So So Wi-Fi means you know very well there will be a router. With that router, it will be transmitting the signal. Whenever you want to use that Wi-Fi, you can able to pick that Wi-Fi with the help of your mobile phone. And then once you are going to move from the place means you are going to disconnect. So depending upon the thing, we can able to use that free access. The free access and easy type of an approval contribute but popularity of Wi-Fi. That is going to be an open sharing model. Large number of Wi-Fi device makes impossible for other service to operate in this frequency band with a reasonable quality of service. Once we are going to deploy large number of Wi-Fi devices, means it is going to be quite impossible for other service. That was the fourth. Next, on to number 2, hierarchical access model. So by the name itself, you can able to fill. There will be a procedure accordingly you want to access the spectrum. So this model assigns different priority to different users. So that will be an hierarchy. So primary users served as if they have exclusive access to spectrum should be served in such a way that they experience the same service quality as if the P spectrum were reserved exclusively for their usage. So that is something that primary and then secondary. Once the primary is going to served if they have exclusive access to spectrum, they can able to serve even though the speed spectrum were reserved exclusively for their user. Secondary users are allowed to transmit but only in such a way that they do not affect the performance or service of quality from the primary user. That was the secondary user. It is also going to be allowed to transmit, but only in such a way they do not affect the performance or quality of service to whom means to primary user. It has to sense the current channel usage first and then they can determine the transmission strategy that does not disturb the primary. So this was nothing but hierarchical access. Even though we are going for primary secondary, it should sense the current channel usage. Based on that, they can able to interrupt or they can able to use the same spectrum which is going to be available, but it should not disturb the primary user. That is nothing but hierarchical access model. The key principle of an hierarchical cognitive radio is that the secondary user does not disturb the primary. That we have already discussed in last point of the previous slide. How means they are going to be approached in 3 ways. What are the 3 ways? Means interweaving, overlay, next underlay. With these 3 approaches, they are not going to disturb the primary user. So what is meant by interweaving? So it is going to be a cognitive radio identify the parts of the spectrum that are not being used at a certain time and transmission in those the spectrum which is going to be sensed. So CR is nothing but cognitive radio identify the part of spectrum that not going to be used for a particular time. It is not going to be used at a certain time and it's going to transmit it to. Next, overlay. The cognitive radio detects actual transmitting signal of the primary user and adjusts its own signal in such a way it should not disturb the primary receiver. That is nothing but overlay. Without disturbing the primary receiver, we are going to transmit the signal. Underlay is nothing but here the secondary radio actually does not adapt to the current environment but always keep its transmitting power spectral density so low that its interference to the primary. That is nothing but underlay. A secondary radio actually does not adapt to any current environment even though it will keep transmitting in their own PSD, that is power spectral density, so that it will go for low interference to primary user. So cognitive radio architecture is going to consist of a radio frequency, analog to digital converter, baseband for. So this will be a cognitive radio receiver. So as in the previous slide, it's going to consist of three. The first one is nothing but RF, radio frequency. Second one nothing is ADC, analog to digital converter, and third one is nothing but baseband processing. So here you can able to see it's going to be a two-way structure, transmitter receiver in RF side as well as in the baseband processing side also we are going for transmitting as well as receiver. In between here we are going for ADC, that is nothing but analog to digital converter. It's going to control the spectrum with the help of an RF and then with the help of a baseband processing. So here both RF and ADC plays an front end of RF, that is radio frequency front end, means it's going to consist of two things. One is RF and another one is nothing but ADC, that is analog to digital converter. So this will be a basic structure of a cognitive radio: RF, ADC, then baseband processing. So in that cognitive transceiver architecture, in a spectrum sensing cognitive radio, only the RF end is different from a conventional receiver. RF front end means here we are going to talk about RF and analog to digital converter. What are the components? Here we are going for antenna, then we are going for LNA, that is low noise amplifier, next local oscillator, next automatic gain control. So with the help of an antenna only we can able to transmit and then we can able to receive. So with the help of an antenna we are going to transmit or receive, means there will be a chance of an signaling. So according to that here we are there will be a noise. So according to that here we are going to use LNA, that is low noise amplifier. It will remove the noise and then it will amplify the signal, so that it's going to be sent to the local oscillator and we can automatically gain the control. Why? Because this gain is nothing but your efficiency, your output. Then only we can able to go for a proper communication from sender to receiver with the help of a spectrum. All the above components should be wideband enough so that they can able to operate at all possible frequency at which the cognitive radio might want to operate. So it is going to be work with the principle of a wideband. Wideband means here we are not going to send the signal, or here we are not going to use this cognitive radio in narrow band. Narrow band means here we are going for only particular. Wideband means it will be applicable for all. So that was the point. All above the components should be wideband enough so that they can operate at all possible frequency at which the cognitive radio might want to operate. Last, in front end of the cognitive radio, an adjustable local oscillator will going to be present. So based on that we can able to adjust. So that only here we are going to have an adjustable local oscillator in front end of the CR along with the RF and ADC. Here we are going to have an adjustable local oscillator. So this is going to be an RF receiver front end. So first we are going for receiver filter, next we are going for low noise amplifier, next we are going for down converter, bass filter, then automatic gain controller, then we are going for ADC. So this will be an RF receiver front end. First we are going to filter that unwanted thing, next we are going to remove the noise, so that we are going for low noise amplifier, next we are going to convert the signal with the help of a local oscillator, next we are going to filter according to the baseband, next we are going to gain the control with the help of an automatic gain control. At last here we are going to transmit that analog signal to digital. So that is RF front end. So now we are going to talk about cognitive transceiver architecture. So in cognitive radio, RF component like LNA, low noise amplifier, can be saturated by an out of band signal that the receiver wants to demodulate at a specific time, but still within all within the overall receive band of the cognitive radio. So this will be the problem. According to that, here we are going for solution. A tunable radio frequency notch filter before the LNA. This will help to reduce the strong interference. However, the hardware cost of such filter is high and the tunability is limited. So once you want to solve the problem, here we are going to place an RF notch filter before low noise amplifier so that it will reduce the strong interference. However, if you are going to implement this noise filter in front of low noise amplifier, the cost of hardware will be high, but the tunability will be limited. For fully cognitive radio, the baseband processing also has to be adaptive, so that the baseband processing is implemented as software on DSP, nothing but digital signal processor. So that's why cognitive radio is otherwise called as a software radio. Why? Because means if we are going to use fully cognitive radio, the baseband processing should be an adaptive one. How it is going to be adaptive one means here we are going to introduce one software that is nothing but DSP, digital signal processing. With this one here we can able to adapt the baseband processing. Next we are going to discuss about interweaving under interweaving and the principle of interweaving. So finding the hole in a overlay system, a secondary user tries to identify the spectral white space and transmit at the time located frequency where the primary user are not active. So clearly the strategy involves three steps: spectrum sensing, spectrum management and spectrum sharing. What is meant by sensing, what is meant by management, what is meant by sharing means, first of all it should sense the hole. Hole is nothing but it is going to be an unused one. We want to sense this unused one and we are supposed to convey to the spectrum management. Based on the spectrum management, they can able to know whoever they want the spectrum for their communication, so that the third step, the unused spectrum, it will be shared to the different users, those who want to communicate. So that was the strategy involved in principle of interweaving. Spectrum sensing, finding the hole. Sensing carried out in presence of noise, so not completed, reliable. Determine the signal level of the detected radiation. So that was the thing. Holes means unused one. Sense is going to be carried in presence of noise. And then here we are going to determine the signal level also. That is, you can able to see the diagram that hole is nothing but spectrum. In between here we are going to have the hole, so that is nothing but it is going to be an unused one. This unused one here we are going to sense and we are going to inform to the spectrum management. The spectrum management will reallocate to the different users for their next spectrum management. As the spectrum management is a secondary system, the part of the spectrum to transmit. Here we are going to see the decision in difficult for reasoning. SS is nothing but spectrum sensing. The spectrum sensing has only casual knowledge of the spectrum occupation. Then spectrum sensing takes a decision on not so reliable the sensing information. So that was spectrum management. Even though the spectrum sensing is going to sense, but it's going to be a casual knowledge of the spectrum operation. Then it takes the decision which is not going to be reliable for sensing information. Spectrum sharing, based on the decision how to develop the free spectrum that the spectrum sensing uses. The spectrum sharing and the spectrum management are strongly related to spectrum might be usable for a particular spectrum sensing but not for others. Here we are going to identify and it is going to be shared to the different users. Next, principles of interweaving and introduction to spectrum. This electromagnetic spectrum. Radio wave occupy the part of an electromagnetic spectrum, a range of electrical and magnetic waves of different length that travel at the speed of light. Other part of the spectrum include visible light and X-ray. The shortest wave have the highest frequency measured in Hz. You can able to see the diagram. lower frequency to higher frequency. The distance from crest to crest is called wavelength. That is end to end. That is one peak to another peak. That is nothing but crest. In wave you can able to see one red color round. That is nothing but crest to crest. The distance from crest to crest is nothing but wavelength in the unit of lambda. The time period t, the time duration in between the crest to crest. How much the time has been taken from one crest to another crest. That is nothing but time period. Inverse of t is called as a frequency. The unit for frequency is Hz. Next, here we are seeing the same example, low frequency to higher frequency. In between you can able to see radio wave spectrum, microwave, infrared, visible light, ultraviolet, X-ray as well as gamma. Here we are going to see the different spectrum from lower frequency to higher frequency. This radio wave, which is going to be an permissible low frequency in this range, are considered more valuable because they can penetrate dense objects such as building made out of concrete. So even though we are going to have the building, but it can able to penetrate and then it can able to transmit from one side of the building to another side of the building. So that's why it is going to be a more valuable. Frequency in this range are considered more valuable because they can penetrate the dense object such as building made out of concrete. Next, microwave. It is going to be semi-permissible, difficult for signal to penetrate dense object. Right. Next, line of sight. Signal in this zone can travel long distance but could not be blocked by tree and other object. Right. Next, here we are going to consider the same thing. The first thing is lower frequency they are going to be used for broadcasting. Next, garage door open. Next, cell phone. Next, wireless medical telemetry. In this aspect, they are going to be used this permissible zone. Permissible zone means it is going to be most variable zone. It can able to penetrate the building which is not going to be out of. So this is going to be semi-permissible zone. Semi-permissible zone means it cannot penetrate. It cannot change the frequency line of it. It can able to travel for a long distance. Nothing is there. So this is the radio service color. So aeronautical, sky blue, intersatellite, light yellow, radio astronomy, dark yellow. So in this way here we are going to represent the color spectrum for various applications. That is nothing but radio.